Hello, everyone. Good morning, good afternoon, or good evening. Dear authors, distinguished session chair, and invited guests. Welcome to Technical Session 8E. I'm Sanskriti Kamkar, and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, that is ICT4SD 2026 in Goa, India. The 11th edition of this conference is being conducted in a hybrid mode. The physical conference was held in Goa, India, while the virtual conference is being conducted via Zoom from 9th to 11 July 2026. I hope you enjoy today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for their presentation, followed by 2 minutes for Q&A. At the 8-minute mark, I will give a gentle reminder so that we can maintain the schedule. I request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during the session, please feel free to share me a message in the chat box. Now, before we begin, it's my privilege to introduce the session chair for this session. This session is chaired by Dr. Santosh Darade, who is an associate professor and the chief operating officer of the Center for Research, Innovation and Entrepreneurship for Young Aspirants at MIT ADT University in Pune, India. With over 20 plus years of experience in academia and industry, he's a distinguished author of more than 21 books on information and cybersecurity, cryptography, and network security, widely used across Indian universities. He has also published over 20 research papers in reputed journals, including Scopus, IEEE, and Sprinter, making notable contributions to cybersecurity and network technologies. We are honored to have him chair this technical session. So, would you please like to share any opening remarks with us?
Yeah, thank you, Sanskruti. It's a pleasure to become a session chair for this 11th International Conference on Information and Communication Technology for Sustainable Development. And as everyone is aware about, the India is moving towards the Viksit Bharat 2047, and sustainable development is one of the national agenda by Prime Minister Narendra Modi ji. So what all the papers that we received, let me check that how they are, aligned with the national and international missions, how this nation is now making themselves sustainable. Let's see how the research is now, whether they are really towards the application development point of view, which will help to the society. Accordingly, let me see that how we can, help each the scholars and the researcher in making their research towards alignment of the Viksit Bharat 2047, making India a sustainable development country. With this, thanks once again for inviting me as a session chair. Wishing all the good luck to all these scholars, PhD holders, those who are presenting paper today. Let's see how we can align with all the missions that we are trying to get in upcoming years. Thank you.
Thank you for encouraging words, sir. Our first presenter is Suyog Tarape, who will be presenting their paper titled AI-based real-time multimodal deepfake detection system using efficient net light with attention. Suyog, you may start your presentation.
Hello, am I audible?
Yes, Suyog, you're audible.
Okay. Good morning, everyone. Myself, Suyog Talbe, and along with my team from Department of Artificial Intelligence and Data Science from AISSMS IIT Pune. I will be presenting our work on AI-based defect detection system defect detection system with efficient net light and attention mechanism. So in short, we have built a system that can catch deep fakes as they happen, using both what you can see and what you can hear. So moving on to the next slide, deep fake and deep learning, deep fake is basically the videos that are made using the deep learning models such as GAN, diffusion models that can alter person's face expressions, voice in the video to its near perfection. That enables real-time harm, misfortune, identity thefts, and financial frauds, etc. And the older detection methods relies on handcraft clues such as unnatural blinking, inconsistent lighting, and those clues simply don't hold up against the modern deepfakes anymore, since they consist of both frame by frame and across motions. And here's a real bottleneck: existing detectors force or trade-off accuracy. Models tends to be shows slow for live users, and fast model tends to be only video only, so they can't be fooled and manipulated by voice. So what we have seen so far, the models are when we reviewed the literatures, we found that the efficient net-based detectors reach over 95% accuracy, but only on modularity. Hybrid and temporal models are more accurate further, but computational cost that hurts real-time performance. Multimodal multimodal system exists too, but they are typically resource heavy but built for offline batches analysis rather than live streaming, and generalize across the datasets, remaining largely unsolved. So our objective was clear: to build a lightweight attention enhanced multimodal system, a system that analyzes videos and audio simultaneously, runs a real-time speed on a computer's GPU hardware, and still reaches 90 to 95% accuracy on celebdf and fake AV celeb datasets. So this is our proposed system. On the video slide, we have attention mechanism with efficient net light backbone. It is a compact that focuses its capacity on a facial regions mostly often manipulated: the eyes, lips, and face boundaries. On audio side, we have word to wake, which is fine tuned to verify whether the speech and the clip is genuine or synthetically generated using lip syncs. These two pipelines run independently in parallel, and their outputs are combined into a final verdict, so the system keeps work even if one modality is available. We also build a full application around this fast API backend interface, a browser based front end supporting both live stream, live webcam, and feed and upload video files. So the system architecture is as follow: the input the video comes as an input, or the audio file is either uploaded or live streams. They get pre-processed such as frame extraction, face detection, or audio file. This From there it is split into two parallel parts, for video pipeline and the audio pipeline. Each production it's producing its own accuracy score. Finally, the fusion stage combines the both score into a final real or fake verdict. The whole system is concentrated with Docker. How the detection and accuracy work? For the video, we simple very fifth we sample every fifth frame to balance thoroughness and speed. Each frame goes through face detection and alignment. We resize each frame into 224 by 224 pixels and passes through the efficient net light plus attention mechanism, which upweights the eyes, lips, and face boundaries. We average all this frame score into a video level score, and for video we extract the track segments into a short window, applying noise reduction and special features with special feature word to wake scores each segment from voice cloning artifacts, and we average those into a audio level score. So the accuracy on CelebDF, we have achieved 42% accuracy uh, with precision of 93.6% and recall of 94%. On the fake AV celeb, harder benchmark, we have achieved 91.8% accuracy overall across both the datasets and datasets that's 93.1% accuracy. On the real-time averages, the interference time is 78 milliseconds per frame, giving us 12 frames per second. On the consumer grade CPU, with the model size of just 45 megabytes, the key points we hit our target accuracy range without sacrificing the real-time requirement and the model and the motive this whole project. How the how does it compare with the prior work? A CNN only detector reaches 80 to 85 to 88% accuracy, but it is partially real time. A CNN plus LSTM improves accuracy slightly higher, but isn't a real time at all. The hybrid of EfficientNet B3 with TCN models actually edge out our accuracy, reaching for up to 94 to 96%, but it is limited and does limited for real-time capability. So our system has reached to 90 to 95% accuracy and is genuinely real time. We are the only in this comparison that's competitive so accurately and actually deployed for live uses. So no system is perfect. Our accuracy is still depends on reliable face detection, which degrades under occultations and extreme edges and angles. We trained only on the two data sets, so the generalization to unseen and manipulated type isn't guaranteed. And scaling too many symptoms scaling too many simultaneously live user would dis- need to disturb interface. False positive and fake negative both will carry the real consequences, so human oversights still remain at high risk and settings. To sum up, we have built a real-time multimodal defect detection system combining attention and efficient net light for video model with word to wake for audio. It achieves the 90 to 95% accuracy at 12 frames per second on consumer GPU and deployed as a complete working application. Thank you.
So how you are claiming that your accuracy level is high rather than the existing one? What are the survey that you made? What are the test cases that you have right now?
So I don't have right now, but I have cross-checked with various datasets, various samples, which I have took from the Google, and we have cross-checked their accuracy using a code and various models.
Validated your database. who has validated your database? And
What,
what is the
sir?
source of your database? What is the source of your database?
So we have took the data set from the Kaggle, which are CelebDF and fake AV celeb.
And who validated your data? Who has validated? It's a valid data.
So who has validated data?
Yes.
Uh,
Take, okay.
ठीक है sir.
So you have to check here after that any system that you are implementing, make sure that the data set must be validated.
Okay, sir.
If someone see Kaggle, everyone is using the Kaggle data. We believe on the data, but there should be some authority should validate the data so that result will get the clear which will match to the existing system, and then you can claim it that we are the first who has implemented it.
Okay,
Getting
sir.
my point?
Yes, sir.
Okay, done.
Thank you, sir.
Yes.
Thank you for your presentation, Theo. Next, we have Pratiksha Gaikwad presenting their paper titled An Explainable Swing Transformer Framework for Automated Peanut Quality Classification.
Good morning, everyone. Is my screen visible?
Yes, Pratiksha, it's visible.
Okay. Uh, Good morning, everyone. I am Pratiksha Gaikwad, and today I am presenting my presentation on an explainable swing transformer framework for automated peanut quality classification, and the college, my College of Engineering, Pune Technology University. These are the content which I will present in this presentation. And let's start with introduction and motivation. Peanuts are a very important agriculture crop, which is a source of oil, protein, and nutrients. So that's why ensuring peanut quality is important for food safety and market value, and also for farmer profits. And traditional manual inspection is time consuming, subjective, and prone to human errors. And also, post harvest losses and mold contamination and storage damage reduce the quality of peanuts. That's why early detection of defective peanuts helps reduce losses and improve profitability. That's why now researchers uses computer vision for accurate quality assessment. In this study, I uses explainable swing transformer for automated peanut quality classification and interpretability decision making. This is a literature review in
Pratiksha,
2022
your voice is too
FS,
low. Pratiksha.
which is achieve 94% accuracy, and the limitation is the it is only focuses on mold peanuts, and it is.
Pratiksha, your voice is too low.
Yes,
Earlier it
yes.
was good. Your voice is too
Hello.
low. Now you're audible.
Hello. Hello.
Yes. It's clear now.
In 2023, improved ResNet 18. Uh, it is actual 90% accuracy, it's a small data set. And below V5s, it achieved 94% classification and sensitive to light 5 automated peanut defect detection using hyperspectral imaging and deep learning. It achieved 95% accuracy, and the limitation is it's a expensive hyperspectral equipment. Research gap. Based on the literature review, several research gaps is in automated peanut quality classification were identified. First one is a limited data set diversity, and most methods uses only binary classification. And third, lack of interpretability. Models works as a black box without visual explanation. And the fourth, dependence on hyperspectral NRI systems for image capturing, and the limited model comparison, not evaluated with both CNN and transformer models. Next, problem statement and research objective. There is a need for low cost and real world deployment model, and expensive hyperspectral imaging system, limited dataset, and black box deep learning models that lack interpretability. To address this, an explainable swing transformer is proposed for accurate, reliable, and interpretable peanut quality classification using RGB images. uh, there is a objective. First one is develop an RGB image based dataset for peanut quality classification, and second, design swing transformer based framework for automated classification of peanut samples, and third, integrate explainable AI for model interpretation, and fourth, to perform a comparative analysis of state of the art models using standard evaluation metrics. Data set. I created my own data set. Around the 20,000 peanut images were collected using RGB cameras, and the data set contains two classes. One is a healthy and unhealthy, and then images were pre-processed by uh, resizing and normalization, and the augmentation techniques used rotation, flipping, and brightness adjustment were applied to increase dataset diversity. The dataset was divided into training set, validation, and testing. These are the healthy uh, peanuts and defective peanuts. Methodology. There is first, image aquacious pre-processing, feature extraction, classification, explainability, output generation. Let's see how it's work. First, the images were collected, and then these images pre-processed using flipping, rotation, and brightness variation techniques. And these processed images provided to the swing transformer, and in this the image were divided into patches, and then the shifted window attention technique extract the features, and then extracted feature provided to the classification layer, and then in this layer predict the output if the image is healthy or unhealthy, and then the heat map generated using the gradcam technique for model decision interpretability. Next, these are the result for model evaluation. I used standard metrics, precision, recall, F1 score, and accuracy. Uh, Achieved an overall accuracy. Model achieved 96% accuracy, high precision, recall, and F1 score for both classes. Strong separation with minimal misclassification, which is shown in this figure, and 78 images model predicted healthy, but it's actually healthy images. Next, this is comparison. Baseline model CNN achieved 92% accuracy, resonate 18 achieve 93% accuracy, and vision transformer model achieve 94% accuracy, and proposed scene transformer achieve 96. There is a 2% improvement, and GradCam highlights region influencing classification decision, and the healthy sample focus on uniform surface texture. There in this image, red color is strongly influence the model to predict the image is a healthy or unhealthy, and the blue color little bit influence the model to predict the decision, and uh, proposed screen transfer achieve the highest accuracy among all compared models. Next, conclusion. An explainable swing transformer framework is proposed for automated peanut quality classification using RGB images, and GradCam++ provides visual explainability, improving model transparency and trust. The system achieves high accuracy and reliable performance compared to baseline models, and the proposed approach is low cost, scalable, and suitable for real world application in agriculture. These are the references. Thank you.
Yes, thank you, Pratiksha. Good. You've done a lot of work. What is the real-time application of this paper that you have presented here? Are you implementing it real time, or so that's the theory that you have converted from experimentation into some result analysis? Does it going to help the farmer?
It is going to help for farmers and also industries. They can use this.
Have you identified the potential areas where it is used, or where it can be used? I'm talking of the specific user group.
Farmers and also for industries. Factories, sorry, for factory.
I know that this is going to use for the farmer, but have you identified any specific areas of the farmers of this field, of these areas where this is the land, this soil fertility of this area is not good? Likewise, have you identified any such use cases where this can be deployed and can be helpful for the actual users I'm talking about?
No, sir, I am not identified.
So
this
that
further.
you have to use. Otherwise, see what I'm trying to say to all those who are presenting. Just our research must be helpful to the user, helpful to the nation.
Yes.
That is what is the objective. So you have presented well, you have selected database, your data is good, your experimentation is good, your result is also good, 96% accuracy is good, no doubt. But ultimately it has to be useful to the people, those who need it. So
Yes,
think
sir.
from the application point of view, whether you can deploy it somewhere, try it for patenting in future. But now result is declared, so you cannot now go for the patenting. But I'm talking about the application perspective.
Yes, sir.
Okay.
Thank you.
Thank you, Pratiksha, for your presentation. Now we have Ishita Khade presenting the paper titled DocuShield, AI-based digital document forgery detection system. Ishita, you may start your presentation.
Yes. Good afternoon, everyone. I am Ishita Kherde, and along with my co-authors Pranali Raikar and Shravani Patil, I am here to present the research paper titled DocuShield AI-based digital document forgery detection system.
Excuse me, Ishita. I'm sorry to interrupt you. This is a request to all the authors and presenters to please turn on their cameras while they're presenting.
Okay. Uh, so our work focuses more on how AI has helped to detect automatically the forged document and in other. So I would like to brief you about problem statement analytic introduction to this system. So in today's digital ecosystem, we know that although widely shared in digital formats, but again now it is easy to share it whether it is authenticate or not. Nowadays, we try to tamper or forge the document by changing the fields like score, name, roll number. So now the existing solution like DigiLocker and other government verification portals, they ensure the authenticity only at the source, like at the time of the issuance. But the problem is again, they rely on manual verification after the issuance of that particular document. So, however, these systems fail to detect the tampering after the document of issuance. Then again, the system failed to identify the modification in specific fields like marks or name, and also they fail to provide real-time automated verification. So now the critical gap is that there is no system check post issuance tampering. Like again, now if we talk about the DigiLocker, it will just store your authentic document, but what exactly happens after that issuance? Some people can again take screenshots and upload it on the websites, so there is no field level forgery detection as well. Now talking about the literature survey, so we have reviewed some of the papers, the past papers, where I have presented few of them. Now talking about Farid of 2009, the technique they used was image forensics. So now again, the limitation that they faced was they could detect the visual forgery like logo, signature and seals, but again they couldn't detect the textual changes. The second paper talks about Tesseract OCR. Now here again, they could extract the text, but again they had problem with image tampering and semantic inconsistency. The next paper of 2020, the technique they used was YOLO object detection. And again, now the limitation was it could detect the regions, but again cannot verify the extracted information. The recent paper of 2022 and 2025, they have used OCR and deep learning techniques, but now they lacked with the semantic reasoning, and also there was limited integration of image and text. So to overcome this problem, we have the solution, that is DocuShield. We have built this complete AI-powered system for real-time field-level document forgery detection. As you can see on your screens, the UI of our system, it has a login button. So, upload his or her mark sheet. It can be image of PDF. Then it will go to the backend for OCR and ML analysis, and it will detect tampered fields, edited text, and suspicious regions. Now, a simple methodology that how it exactly works is, first, a user will input a document. It can be any mark sheet. Then it will be pre-processed. That now this system also validates every data, but the quality of the image should not be like blur or anything. So it is first pre-processed at the backend, like reduces noise using Gaussian blur, and then also resizing the image. Then it will go to the YOLO V8N detection. So now we have used this object detection model, that is YOLO V8N, the nano version. The reason we used this nano version is as it is lightweight and it gives high accuracy. So it will detect all the fields that are there on the mark sheet at once. Then field localization. So every field will have a bounding box. So to like we have to predefine every position of every.
What happened?
Hello.
Yes, Ishita, what happened?
Am I audible, sir?
Voice is breaking, Ishita. Your network is, I think, very slow. Bandwidth is slow.
Uh, am I audible, sir, now?
Yes, yes, yes. Little.
Uh,
Good, good, much better.
so after the YOLO V8 detection, it will go for the field localization. That is, it will apply the
Share
bounding
your
box.
presentation. Can you share your presentation?
Okay. Is it visible, sir?
Yeah, it's visible.
So after the field localization, the all the text will be processed by OCR. Here now optical character recognition will extract the text and it will be again given to AI analysis, that is Gemini. Here now the text will be converted to base 64 so that AI could detect it. And again, the whatever the communication is happening between a front end and the back end, it will be done using the mechanism that is cross origin resource sharing. Here again the Gemini is highly used to for the semantic analysis. It will understand the context behind every field and it will detect whether there is some overlapping bounding box over that particular field, and then it will check whether the field is forged or not. Then at the result it will give you the result as authentic, suspicious, and needs review. Now authentic means that the complete document is not forged, it is authenticate. And the second one is suspicious. Now if the complete document is forged with high confidence score like 99 or 100%, then it is suspicious. And then third one is needs review. If there are like one or two fields out of all the fields that are detected with low confidence score around 60 to 70% of confidence score, then it is detected as needs review. So this is the workflow. The only thing I would like to add in this is that it is basically a UI. So first of all, user will have to register using their email ID. The first user, that email ID will be stored at the backend, that is MongoDB. And then again at the time of login, the user has to use the same email ID where they will receive a 6-digit OTP, which will validate that the user is authenticate. And then user has to upload a document and then the system will validate the file format and integrity. So now I would like to talk about the result analysis. So here user has to upload a document. Now the whatever the text is extracted by OCR, it will be shown on the UI as well. And then it will take about 1 minute for the verification result. And then for genuine certificate verification, it will give as authentic as a result. The second one is invalid document. That is when you upload any document that is not a mark sheet or anything, then it will directly give you that it is an invalid document type. The next one is needs review. Now as you can see on the result, there are some of the forged fields that are detected. So out of 5, there are 2 suspicious regions and there are 3 authentic regions, out of which like certificate ID and name. And the confidence score you can see is about 70%. So it tells that it needs a review. The next one is a suspicious document, that is completely forged document where name, roll number, SGPA, CGPA, and certificate ID is forged. So you can see that it will also give you explainable result with the confidence score and also a report. Now the unique
Excuse
selling
me,
point.
Ishita.
Yes.
Sorry to interrupt you. This is a gentle reminder that 2 minutes are left for your presentation.
Okay. So the unique selling point of our project
Sanskruti,
is
just
that
check the
how it
time limit.
stands out.
What is the time limit that Sanskruti just keep on watch the time?
Okay. So I just want to say that how it is, how it stands out. It is because field level detection is there. Lightweight YOLO V10 is used for real time inference, and the most important thing is that there is no dependency on government database. This is a small comparison with existing system like DigiLocker and traditional method where there is no AI analysis and post issuance detection is also partial. And I would like to conclude by saying that we have developed a DocuShield that is complete AI-based forgery detection system. It has integrated YOLO V8 for document region detection, OCR for text extraction, and AI-based semantic analysis. The system also provides region level forgery detection along with explainable results. Now, the future scope I want to talk is about is that we could support multiple documents such as passports, Aadhaar card, but we initially just focused on one type of document, that is mark sheet, and we could also integrate it with government database and institution, and also develop a mobile application for instant document authentication. Uh, so these are the references.
Yes, yes. So Ishita, that already we have the government have given some document shield. There's a document verification application also available. How your application is different from that?
So, sir, what we thought is that, like, we want to give the explainable results. It just don't. It shouldn't just be that it is forged or not, but we want how the users can actually rely on our system that what particular document is forged,
So
and for that we also.
DigiSign is there, right? DigiSign application is there. Government of India, DigiSign. So DigiLocker is also there. So
So,
they
sir, about DigiLocker, I would like to say that the problem is that we can actually store our authentic documents at the issuance. But what exactly happens after that? People can still screenshot that image and then again upload it for like recruitment process or even mark sheet at the time of admission, and then they can tamper it. So for that, we thought that we can develop a system, a lightweight system which everyone can use. And so we have also validated using our own mark sheet as well, if it works on our mark sheets as well. So it works. So that's how.
okay. So just last question, Ishita. How many images that you have validated so far?
Sir, about 345 images were there, out of which 50 to 60 images we tried to test along with our own mark sheets.
And what is the outcome that you got? What
Sir,
is the result?
about we achieved about 92% of accuracy. I couldn't say it about 100, but till now we can say that 92% of accuracy.
Okay, so just my doubt is that if the government have the DigiLocker, then if you implement in future, how do you think that people will start using your application?
Yes, sir. If we try to means integrate it with their system as well, and if they need more easy way to log in and directly upload their mark sheet and get instant results, so it is possible.
Okay, okay, all the best.
Thank you.
Thank you, Ishita, for your presentation. Next up, we have Priyanka Shinde presenting their paper titled Ensemble-Based Uncertainty-Aware Self-Supervised Transformer for Robust Time Series Solar Flare Forecasting. Priyanka, you may start your presentation.
So good afternoon, everyone. Myself Priyanka Shinde. I'm on ensemble-based self-supervised for time series solar flare forecasting. My co-authors are Aparna Biswas and Archana Patil. So let's begin. So let's begin by the introduction and motivation for this work. So let's first understand what are solar flares. Solar flares are kinetic energy that leads to high electromagnetic radiations. So solar flares can be classified into 5 classes, that is A, B, C, MX, out of which the M and X have high intensity solar flares that can impact satellites, GPS, and even power grids on the Earth. So the problem with the existing models is that they rely highly on supervised learning, so they require large label data set. Also, they suffer by several class imbalance, as we know that high solar flares are quite rare, and the data set is more majoritarily occupied by the data of rare small and A and B and C class solar flares. So predicting of M and X solar flare is quite difficult due to the data set being class imbalanced. Also, the existing models do not provide a confidence estimation along with the prediction. So the goal of this paper was to develop a robust uncertainty aware framework that improves both prediction accuracy and reliability for operational forecasting. So the literature survey, here are some papers that I have gone through. So the current papers use transformers and they have shown a high accuracy compared to other models. And also they use only supervised learning. Currently, there is no paper on self-supervised learning approach. There, some papers have introduced uncertainty estimation, but they are for regression problem, not for binary classification problem. So the gaps that were identified were that the data set is there is dependency on large label data set, and there is poor detection of M class solar flares due to severe class imbalance. Also, there is a lack of uncertainty estimation for the reliable decision making. So the problem statement was to develop an accurate and reliable framework for forecasting greater than M class solar flares using HAD dataset. So we have used SimCLR self-supervised learning for this. Also, we have used the transformer and focal loss to handle the class imbalance. And we provide estimated epistemic uncertainty using the deep ensembles. So the dataset is HAD dataset that consists of magnetic field parameters. It is taken for a 24-hour observation window consisting of 40 time steps sampled each at 36 minutes, and the target is to classify into larger than M class solar flare, or it is not an it is less than M class solar flare. So we have done standard data normalization, and also the validation strategy that we used is 10-fold active region isolation. So the data set was divided according to active regions, so there is no data leakage. So this is the flow of the architecture. So first the time series data is injected into the model. Then there is some stochastic augmentation is performed on the data. So we augment the data for noise, masking, and cropping, also scaling. So this helps in learning and understanding the data. Then it is provided to the transformer encoder model, which consists of 3 layers and 4 heads of a dimension of 128. So this is divided into 3 stages. So the first stage is the self supervised learning that uses contrastive learning. So here the data is projected using projection heads, and here the NT-Zend loss is calculated. So we want the uh, data with same flares to be close, and data with different flares to be far from each other. So this is the objective of the stage 1 learning. In the stage 2, we add a classification head that calculates the focal loss, and it tries to minimize the error. In the stage 3, we use uncertainty
quantification. So here deep ensemble is used with different seeds. So different seeds transformers give their outputs and mean is calculated of them, and the mean TSS is generated. So these are the stages as I explained previously. So the stages in the stage 1 there is self-supervised pre-training. In stage 2 we go to supervised fine-tuning, and in stage 3 there is uncertainty quantification. So these are the results. In the table 1 we can see the results compared to the baseline. So the baseline papers use some different data sets as well, like Sharp. So their performance is shown here, and we can see that the proposed transformer performed quite better than the baseline models. Also, we can tell that HUD dataset is better than Sharp dataset for prediction of solar flares. The ablation study confirms that integrating a SIMS-LAR and focal loss and the complete pipeline delivers a consistent forecasting performance by successfully dropping the standard deviation from 0.08 to 0.07. So this is also some graphs that I have computed for the uncertainty distribution and accuracy. So as we can see, it is rightly skewed. So as the uncertainty decreases, so as the model is more certain of its results, the accuracy increases. This can be seen through the graphs. So conclusion for this is that we got a framework that with self-supervised transformer and ensemble, deep ensemble for forecasting large greater than M-class solar flares. It achieved an accuracy of 0.76, which is outperforming the existing baselines. Also in this model, we have introduced a filtering method where you can filter out the top 20% most uncertain prediction for better operational boost and stability. These are the references of my paper. Thank you.
So Priyanka, what is the size of the database?
Consists of 10 active region data sets, 10 active region full data sets. So it is approximately consist of 26,000 samples or dimensions.
And which algorithm you have used to pre-process it?
So for pre-processing, I've used standard normalization to bring it to us scaling.
Okay. And how you have done the data labeling?
So it was label data that I have used, but for self-supervision, I did the augmentation of that data set so that I can have a pre-training at the start using self-supervised where the label is not provided, but augmentation is done.
So what is the source of the data from where you brought this data?
So I have taken the data set of my base paper from their data set I've used, so I can compare it properly, baseline the paper.
Okay. 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 Thank you. I'm done.
Thank you.
Thank you, Priyanka, for your presentation. Now we have Yasira Khan presenting their paper titled LAHBLT++, a CTC safe transformer framework for robust Urdu handwritten text recognition. Yasira, you may start your presentation. Yasira, if you're speaking something, you're not audible.
Make it the slideshow mode.
Isira, can you hear us?
I am audible.
Yes, Hira. Please start your presentation mode.
I am audible.
Yes, you're audible.
Press F5 button so that it will show the slide.
Hira, can you hear us?
Screen is visible.
Yes, your screen is visible. Can you please press F5, the button F5, fifth function key?
I already pressed F5, but the screen is not visible.
You stop sharing and share it again. Share the entire screen so that all the changes will get reflected.
Okay. Mhm. Screen is visible.
Yes, it's visible.
Okay. Research title is Literature Aware Hybrid Vision Language Transformer, a CTC safe transformer framework for robust Urdu handwritten recognition. Introduction. In this digital era of machine learning and artificial intelligence, how can we extract the degraded text? So OCR method, optical character recognition method, is used to convert handwritten or printed text image in machine learning and readable text image. Urdu handwritten OCR play a vital role. A Nastaliq writing style is one of the most challenging script due to cursive nature and complex character. Nastaliq writing style means it is a font style of Urdu language. Mm, After introduction, motivation and objective. The motivation to make OCR model for Urdu text is cursive Nastaliq script with connected character and ligature, non-linear baseline and irregular handwriting style, historical document degradation, faded ink stain, proper paper damage, broken stone. Objective or develop a robust CTC safe transformer framework. First, preserve sequential information, improve recognition accuracy, provide stable alignment without explicit character and segmentation. In our next slide, dataset and pre-processing. Dataset UTR set, real dataset we are using. After dataset, pre-processing pipeline. In pre-processing, we pass an input image resizing, standardized image dimension 64 ratio cross 1024. Contrast enhancement, binarization, text normalization, data augmentation, pre-processed image. After pre-processing, overall network framework. First we pass an input image. After input image pre-processing, image pre-processing a CNN feature extractor. CNN feature extractor extract low-level language and high-level language visual feature from handwritten image. After CNN extractor, width-wise feature extraction. Width-wise feature extraction means convert 2D feature maps into 1D feature sequence. Maintain the natural left to right reading order. Positional encoding. Positional encoding means add positional information to each feature. Enable the model to understand the order of character. Transformer encoder. 6 encoder layer plus 8 multi-head self-attention head. Hidden dimension. Linear projection plus CTC layer. Linear projection. Projection means project encoded feature into character probability distribution. The beam search decoder select the probable character sequence after output recognized Urdu text. Result analysis. In result analysis, evaluation matrices CR 0.234 for normalized CR 0.2646, word accuracy 87%, validation CR 0.2406. Comparison table. In existing methods, CRNN with architecture CNN plus Bilestream plus CTC, word accuracy 61%. CNN RNN plus hybrid, word accuracy 65%. MMU plus OCR, word accuracy 69%. UTR net CNN plus transformer, word accuracy 74%. TROCR plus vision transformer 79%. Our proposed method hybrid vision, ResNet plus transformer plus CTC 87%. Evaluation study. Evaluate the contribution of each major component in proposed framework. ResNet plus CTC से higher CER था, plus transformer हम उस encoder ऐड किए तो CER decrease होते गया. After positional encoding CER और decrease हुआ. Beam search decoder lowest CER. Quantitative result. Major contribution: novel CTC framework, improve feature representation, enhance constructual learning, improve decoding accuracy. Conclusion: developed a transformer-based framework, combined ResNet transformer encoder, CTC decoding for robust and end-to-end recognition, provided a reliable solution for recognizing degraded historical text. Future work: develop lightweight and real-time version for mobile and edge device, integrate large language model to improve contextual text correction, investigate self-supervised and constructive learning to reduce label data requirement. There are some references. Thank you.
Okay. So Yasira, from where you collected this Urdu language handwritten text?
Data is publicly available in Kaggle and different many sources.
Have you tested it on a real-time database?
Yes.
What is the result?
Result.
Because your accuracy level is 87%. So how
Yes.
people will recognize the correct data? So everyone wants the actual
Real.
conversion of text, Urdu text.
Yes, real time data set पे भी हम उसको ट्राई करके देखे थे तो एक्यूरेसी लेवल वही थी 85 to 88% के बीच पे ही वेरी कर रही थी.
तो आपको बढ़ाना पड़ेगा ना उस एक्यूरेसी को, क्योंकि क्या होगा, ये तो रिजल्ट एक्यूरेसी 87-85% है तो so it's difficult for understanding then for people.
Okay.
तो चेक करो how you can real time text and
Yes.
improve the accuracy.
Yes, I am working on it.
ठीक है, okay.
Okay.
Thank you.
Okay.
Thank you, Yasira, for the presentation. Now we have Shravani Kamre presenting the paper titled Maratha Weapon Classification Using YOLO Weed on a Curated Cultural Heritage Image Dataset.
Thanks, Sanskriti. I hope I'm properly audible and visible too.
Yes, you're audible.
Yes.
I'll just share my screen. I hope my screen is visible.
Yes. Make the big
Okay.
screen.
Yeah, I'll put it in the slideshow mode. Is it fine?
Yes.
Okay, thank you. So good afternoon, everyone. Respected session chair, distinguished guests, and estimated viewers, fellow researchers, and all the presenters. It's my privilege to present our research at the International Conference on ICT for Sustainable Development, ICT4SD. I would sincerely like to thank the organizers of ICT4SD. So I'll introduce myself in short. I'm Shravani from International Institute of Information Technology, Pune. So my paper title is Maratha Weapon Classification using YOLO V8 on a curated cultural heritage image dataset. This work has been carried out in collaboration with I2IT Pune and Me Too Research. Our researchers have two major contributions. First, we developed the Maratha weaponry dataset, which is firstly publicly available on two domains, which is called as Mendeley data and IEEE data port. Second, we have trained the deep learning model using YOLO V8 to automatically classify these historical weapons, thereby contributing to the computer vision research and digital curated heritage preservation. So let's get into the historical context. Before discussing the technical aspects, it's important to understand the motivation behind this research. The Maratha Empire, founded by Chhatrapati Shivaji Maharaj, played a significant role in Indian history. Their military strength was supported by advanced weapon design, high quality wood steel material and metallurgy, and the famous guerrilla warfare known as the Ganimi Kawa. Today, many of these historical weapons are gradually deteriorating due to the age and environmental conditions available. While some collections are preserved in museums in Mumbai, Pune, and Kolkata, many valuable artifacts remain with private collectors and are rarely not digitally commuted or accumulated. This lack of publicly available digital archive creates challenges for historians, archaeologists, museums, and researchers. Therefore, our objective was to digitally preserve this important heritage while applying artificial intelligence for automated weapon classification. As the session chair rightly said in the start of the session about Vikasit Bharat, even we have an ideology regarding India's building culture, technological culture rather. This work aligns with India's vision of leveraging artificial intelligence for culturally preservation through initiatives such as Digital India Program and India AI Mission launched by the Government of India under the leadership of Honorable Prime Minister Shri Narendra Modi. This initiative encouraged the responsible use of AI, digital technologies to preserve India's rich cultural heritage and make it more accessible for the future generations and the upcoming Gen Z is what we call. So the Maratha weaponry data set, as I've earlier said that this is the data set curated by us, like my whole team. The first major contribution of creating this Maratha weaponry data set, we call it as MWD. The dataset consists of 187 images representing 15 different categories of the Maratha weapons. The images were collected from three primary sources: museum photography, private collectors, and authenticated online repositories. So, as we move on further, I'll be describing from where have we collected the data. To ensure reliable model evaluation, the dataset was divided into 70% of training and 15% of validation, and again 15% of testing. Each image also has each image is contained in the metadata, which was moving into the format of source, the capture method, the historical period, the material, and the provenance. To encourage future researchers in computer vision and cultural preservation in the dataset, this has been publicly made available on IEEE data port and Mendeley data. You can access it anytime. So let's talk about the main technical aspect of it. Data pre-processing pipeline. A high quality dataset is essential for building an accurate deep model. So therefore, we designed a comprehensive seven-stage pre-processing pipeline. The pipeline includes image collection, data cleaning, expressing the labeling, resizing the image, background removal, augmentation, and finally the quality verification. For background removal, we use the U-square net model, although approximately it's 11% images required manual corrections to improve segmentation quality. Now, as the dataset was curated by us, we had a lot of problem while augmenting the data because of the availability of the Maratha weapons, available digital archiving, which is not present online anywhere. Similarly, during labeling, whenever experts had different opinions, discussions were conducted until a consensus was reached. So, our guide from the Me Too research, Mr. Tushar Kutte, and our HOD, who's one of the co-authors of the paper, Dr. Jyoti Surve, they were constantly looking after this, like how are we curating the data set. There were discussions like whether to keep this class or not, or whether to um, emphasize on which of the particular class. Like we have a lot of images of swords available, lot of images of dhal available, but the classes like Khanjar or Bichwa, there were very less images available. So there were continuous discussions on it. These quality assurance steps ensured that our data set was consistent, reliable, and suitable for training a robust classification model. So let's talk about the results and the analysis. Model architecture and training. For weapon classification, we selected the YOLO V8 classification version with the YOLO V8 architecture. The model contains approximately 5.1 million parameters and uses ImageNet pre-trained weights, allowing us to apply transfer learning effectively. Training was performed on Tesla T4 GPU using Google Colab for 50 epochs and the Adam W optimizer, which is an inbuilt for Google Colab version. Each image was resized to 512 by 512 pixels, and automatic mix precision was enabled to improve the computational efficiency. The complete training process required less than 1 hour, while the model performance inferences from 5 to 12 milliseconds per image, making it suitable for real-time application. So talking about the scores, which you can see right now on the screen. So you can see that the total top one accuracy is 78.95 on 190 test images. Now, comparatively to whatever models we run, it is a little bit lower. The reason behind is it YOLO V8 also requires a huge data set. And right now we have curated about 1,787 images only. So getting a proper accuracy with 15 classes and a less number of data set is a little bit difficult. And keeping the originality in mind, the accuracy what we are getting is 78.95. The macro F1 is 76.68%. It is indicating the balanced performance across all 15 weapons categories. And then also we have achieved an excellent macro specificity of 98.9%, which means the model rarely misclassifies unrelated air weapons. We have tested it properly, like not on real weapons, but yeah, we have the images available. You can simply Google an image. We have an app developed. You can just scan it and you can just predict what kind of weapon it is, when it was built, and the history behind it. Additionally, a macro AUC is the area under the curve, is of 0.8745, demonstrates strong overall classification capability. Some weapon categories such as Dhal, Firangi, Cannon, Indian bow, and Katyar achieved outstanding performance because they possess distinctive visual characteristics. However, categories including Jambia, Khanjar, and Bichwa remain challenging because of the highly similar curved blade structures. As we know that most of this Jambia, Bichwa, they have a similar kind of structure. So it becomes difficult as there is less number of data also available on it, and they have a similar kind of structure too. So which was very difficult for human experts also to distinguish them properly. Similarly, the lower performance for Khanda was mainly due to the limited number of testing samples rather than limitations of the model itself. Overall, these results demonstrate the transfer learning and the YOLO V8 is highly effective for specialized cultural heritage datasets. So let's talk about the app. Okay, but before that, I'll get into detail with the model architecture. So if you see the system overview, you can see that as a user, you can use a camera, scan, or whatever if you have collected before, like a
Excuse me,
weapon image
Shravani.
gallery if you have. Pardon?
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentations. Please conclude.
Thank you so much, Sanskriti. Okay, so after the camera scan and the weapon image gallery, it is going through the AI model, which has the YOLO V8 and the transfer learning implementation. Then the image is pre-processed, the resizing is done, And if the weapon is not classified, it shows an error. If but as we have a good accuracy rate also, so like 78, and then weapon classification is done. So we get the weapon class, the weapon information, and there is a feedback also. Like if you feel, if you are an archaeologist or you're a researcher, you know better than what we have done, then you can always give a feedback to us. And this is the training time and the inference time. As you can see, the Google Colab has a Tesla T4 inbuilt GPU, and then AdamW optimizer with 3 epochs and 512 pixels with an image net preprint, which I've earlier explained. So the mobile demo and the future work and conclusions. To demonstrate the practical applicability of our research, we have also developed a mobile application using either device camera or an existing gallery, as we have seen in the system architecture. Within milliseconds, it provides both the predicted category and the historical information. Looking ahead, we have a plan to expand the dataset to 5,000 images covering to 20 weapon categories. We also aim to explore advanced architecture such as vision transformers, attention-based models, 3D scanning, then augmented reality, AR, VR, what we call, and the XRF spectroscopy for detailed metal analysis and the material analysis too. In conclusion, our work includes the first open benchmark dataset for the AI-assisted Maratha weapon classification and demonstrates how the YOLO V8 with transfer learning can successfully support the digital heritage preservation. We believe that the research creates a bridge between artificial intelligence, computer vision, and India's cultural heritage, contributing toward the sustainable digital preservation while supporting the broader vision of digital India and AI-driven innovation. These are a few references. The first two are the data sets which we have published. Then third is the Redmond and Divala Grishik, how there is a the published paper on in the IEEE conference on computer vision. Then we have the Bochwisky and Wang Leo optimal speed and accuracy for the object detection main method. Then our co-author, Dr. Jyoti Surve, we have used her papers also for as a references, which were on the YOLO V8 detection. YOLO V8 as well as computer science and AI ML cloud form papers. Then we have the main catch of it, like we have personally visited the museums in Gwalior we have the Jaivilas Palace. Then in Jodhpur we have a museum, the Umed Bhavan Museum also, and in Pune we have the Holkar Museum and the Holkar Library also, the Deccan Historical Society Press of Pune, and then Sahyadri Publications have again of this vast data set already, but it is in a smaller version. And the digital archiving of military artifacts, whatever was available. So we've personally gone to places and collected the images and everything. So concluding, I will once again like to express my sincere gratitude to the session chair and organizers of the ICT4SD, all the reviewers, everyone present here, and for the opportunity to give me and present this topic here. Thank you, and I'm open to questions.
Yes, Ravani. So it's very good that you are doing some traditional Maratha work that has been mentioned. Yes. But where you are going to use this from the application point of view? Who are the
Yes.
user of this?
So basically, we have many researchers and collectors, art collectors nowadays, like who are consistently working on this data set still. So when you get a weapon, for example, you go to the carbon dating process and just to find the weapon it belonged to the era, whatever. So the researchers, archaeologists, and the Archaeological Survey India, ASI, basically, they require such kind of softwares because they are continuously digging everywhere. They get the weapons, but sometimes they don't have the app knowledge to classify them. So researchers,
No, but
archaeologists,
from where means what is the source of this weapon? Who has given this to you? Does it taken from the Maharashtra State Tourism Department or the actual source where it is validated that this is the correct weapons? Who has validated this?
so we have a few researchers who are collectively working on this already. Like the sponsor of this, one of the sponsor of this project was Me Too Research. So Mr. Tushar Kote, he has a lot of researchers contacts who are working in this field since past 15, 20 years, who have a good experience of this data. Then we have writers of the books who have published the Maratha books and they have an apt knowledge of it. And also the museums like even Jaivilas Palace in Gwalior and all, they have already classified these weapons into their proper itineraries or the directories. So
Okay.
we have taken the data from there.
Okay. Okay. ठीक है. Just validate the database from the government authorities, these
Yes, sir.
ministries, because if you are going to showcase to the world, it must be
Yes.
validated by the governments.
Yes, sir, definitely. We're planning to
Okay.
expand it and just bring the archaeological survey of India
Yes. Yes.
to
Okay.
get on board for this.
ठीक है. Okay. Okay. Yes.
Okay. Thank you, sir.
Thank you, Shravani, for that refreshing presentation. Up next, we have Chinni Bhanu Prakash presenting their paper titled Multimodal Deep Learning Framework for a Fake Disaster News Detection Using Decision Level Fusion.
Yeah, so good afternoon, sir. Good afternoon, ma'am. Just I'm sharing my screen. Are you audible, ma'am?
Yes, you're audible. Good
Yeah.
afternoon.
Cool. Yeah. Yeah. Good afternoon, sir. So my name is Chinni Bhanu Prakash. I'm from Siddhartha Academic of Higher Education. So coming to my others are Dr. T. Anuradha. She is our professor, and also the Sheikh Nia Jasmine. And I am from Information Technology. So coming to our project, the project is about multi-model deep learning framework for fake disaster detection using decision level fusion. And yeah, let's go to the next slide.
Sorry to interrupt you, Bhanu. Can you please turn on your camera?
Yeah. Yeah. I think my screen was stuck. Sorry, just a second. Yeah. 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 Sorry for that. So coming to introduction. So during disaster situation, a lot of information is spreaded over the social media platforms such as Twitter and also the media platforms. So mainly people use Twitter or any other social media to gather the information about the disaster related information. So social media can spread the real information and also the fake information. So there is no any limit for spreading the fake information. So by this fake information, people may misguide and also they may cause panic by seeing the misinformation or we can say the fake information in the social media. So they may not trust the genuine information of the disaster. So for this, we need a automated system which is capable to identify whether the particular information from the social media is real or fake, and also whether it is a disaster or not. So our main motivation to do this project to build the system is to that social media is spreading a large amount of fake information and also the disaster information on social media, and this spreads within minutes entire the world. So this causes people to panic and also confuse, and they may not take the real information seriously. And so that we also analyze the existing systems of these similar projects, which they mainly focus on the text based, not on the images also. So whereas social media post both text and also images on the particular platforms. So the model is the existing models are only based on the text, and they are also not identifying whether particular disaster is real or fake. So our motivation is to build a multi-model deep learning framework that combines both textual and visual information to detect whether it is a fake disaster and also to detect whether it is disaster or not. So coming to problem statement, the main problem is to distinguish between whether it is a genuine real information or it is a fake disaster information. So manual verification for this distinguish between real or fake is impossible with the large amount of data, and existing models are only unimodal. They are identifying whether using text or whether image. So we build a model which is which is a multi-model which identify disaster information fake or real by using Robota and ResNet 50 models. So coming to objectives of their particular project is to develop a multi-modal framework for detecting whether it is a disaster or not. And so for that, we fine-tuned Robota model, which is used for the textual feature extraction, and also for the ResNet 50 model, which is mainly focused on the images. And by after combining these both outputs, we did a decision level fusion strategy to combine both the text output and also image output, and therefore the accuracy was much better than the unimodal. And coming to outcome, the final outcome was a multi-modal framework, which is very accurately detects whether the particular information is fake or real. And we individually fine-tune the Robota model and the ResNet 50 model. And so, yeah, this is the outcomes of the particular project. And so coming to data set, we used FEMI data set for identifying whether it is real or fake classification, and disaster-related P data sets such as crisis MMDA. So these data sets are used to distinguish whether it is a disaster or not, and also the fake or real information. So this includes like earthquakes, wildfires, and floods. And for the disaster image data set, these mainly focused on the ResNet 50 model. So this help us to identify what is the type of the disaster in the images by looking into the image. So whether it is flood, fire, or earthquake. So these are the data set we used. And coming to architecture diagram. So this architecture diagram mainly focused on three components, but one is individual pipeline of the text data and image pipeline, and combining both the outputs, and we did a decision level fusion. So we will see the architecture diagram step by step. So coming to tweets pipeline, we took the tweets data set and we pre-processed the text from the data set, like cleaning and removing the spaces and all other the things, and then we pass the text information to the fine-tuned Robota model. So the task of this Robota is to identify whether the particular text is real or fake, and also whether it is disaster or not. So parallelly, we took the image data set, and we did the image pre-processing, resizing the image and also normalizing, and then we pass the data to the fine-tuned ResNet 50. Whether the task of this ResNet 50 model is to identify what type of disaster it is by looking into the image. So we get the output of the two models separately. Then we did the decision level fusion, which combines the outputs and which results in the better accuracy compared to unimodal. So now it became a multi-modal framework. So then the final classifications are, we get the output as whether the information is real or fake and disaster or not. Whether if it is disaster, then what is the type of disaster it is. So this is the architecture diagram. So let's go to results. So this is the results which we uh, we took the real data from the Twitter. As you can see the right side, the text from the Twitter, which we are given here as input, and also we can upload the image of the particular information from the Twitter. So our system is analyzing the content. Uh, you can see the diagnostic results, like whether what type of disaster it is. If it is disaster, is there any damage? And you can see the authenticity, whether it is real or fake information, and also the detected location by using the name entity recognition. It detects the location of the particular information and also the priority level. And we also did few examples by taking different information from the Twitter. So this input is nothing but they are conducting a exercise for the emergency rescues. So this is not a particular disaster, just they are practicing how to rescue. So our model correctly identified it is not a disaster and is a real information. So it is predicting. And so here we took the fake AI generated information from the Twitter itself. You can see the image is an AI generated and the tweet is uploaded in the Twitter. So we uploaded the text and also image from the Twitter. And then our model is predicting correctly it as a not disaster and it is a fake information. Yeah, so coming to interface results, so this is the left side, you can see the disaster tweet dashboard. It is continuously fetch the latest tweets from the latest tweets, and also it will identify the location of the particular disaster it happened. So which we use to leaflet maps from the library for the using this. And coming to result analysis, so this is the ResNet 50 results, which are confusion matrix and also graph of the training and loss. So you can see the confusion matrix, the diagonals, which the model is accurately predicting from the different categories, like such as cyclone, earthquake, flood, and different categories. And also we have some misclassifications here and there. And coming to the graph, there is a train loss and the validation loss, which we can see the both lines are going down from the epochs 1 to 15. And the both lines are close to each other, where we can identify that the model is learning correctly and there is no overfitting. And coming to the Robota model, the main task of the Robota is two tasks. One is to identify real or fake, and the second one is to identify it is disaster or not. So you can see the graphs, training loss and validation loss of the particular Robota real or fake detection, and also the confusion matrix, where you can see that it is correctly predicting actual positive and the predicted positive, whereas actual negative has a predicted negative 3935. And coming to Robota model only, it is for the disaster or not. So you can see the graphs of the training loss and validation loss and also the confusion matrix for disaster versus non-disaster classifications of the Robota model. And both training loss and the validation loss are accurately decreasing from epoch 1 to epoch 5, whereas we can identify the model is learning perfectly. And so these are the individual results of the particular Robota and Resident 50 for fake or real disaster or not prediction. So our main aim of the project is to do the decision level fusion as a multi-model. So you can see in the table, the Resident 50 model task is to identify the what type of disaster it is. And we can see the accuracy, it is like 85%, the Resident 50 single it is giving. Whereas Robota, there are two tasks for the Robota model. It takes the text and identify whether it is disaster or not. If it is disaster, then what it is real or fake, it identifies. So we can see the accuracy 88% and 84% for the Robota model. Then we did a decision level fusion, which we comment all the outputs of the particular models, and we can see the accuracy was much more higher than the individual models, so which is 90%. And here we can see the confusion matrix, which we given the unseen data for the model, which it predicted correctly. And yeah, coming to conclusion, I want to conclude that we developed a system which is multi-model framework for detecting whether particular information is disaster related or not. And if it is disaster, it also identify whether it is fake or real by using Robota model for the text analysis and President 50 for the image classification. And also not only generating real or fake or disaster or not, we are also giving additional information such as location of the information and also the type of the information and also the urgency of the particular disaster, and using the named entity recognition and so on. And so coming to future work, we want to So right now we are only taking the text and image from the particular information, right? So in future work we want to add the video and also audio from the particular disaster events. Like social media also spread produce information like videos and also the audios, right? So this is want to implement in the future, and also include AI for the explanation of the particular information, disaster information. And so, yeah, this is the thing we want to do in the future. And yeah, that's all from my side. Thank you.
So how it is going to help the media to predict the accuracy? Let's say because media has that job to give that whether the information is correct or not. They look into the actual evidences. So
yeah, yeah, sir. Yeah, sir. But in the social media, not only the media will can keep the information, right? A common man can also spread the fake information, right? So that is why we develop this model. Like a common man, like any politician or like you and us, we can also tweet the information in the Twitter, right? So at that time, they may can also produce fake information wantedly.
yeah. So from where you are going to get the database of it to check whether it is a fake or real this thing.
Yeah, we took the dataset from the Kaggle, which is a FIME dataset, which is the model trained on that particular things such as real or fake, which the dataset contains the labels as text, real or fake, and some models are trained on particular data, and they are predicting on the unseen data also accurately.
So have you trained the data, real-time data, and have you checked the results for that?
You are telling like we have trained on the given data for the real time data, but we didn't train on the real time data, but we given the real time data as an input, and it is the generating the output correctly.
So from where I'm saying, that's why I'm asking that from where you collected the real-time data. See, Kaggle is the data is that you can do it for the testing purpose for
yeah,
validate the result. But from where you collected the real-time data?
so we didn't train on the real time data, sir. We only tested with the real time data.
Okay, tested. So that's
Yeah,
what, so I'm talking about the
yeah,
tested, but for testing, from where you have taken that data?
from the Twitter only, sir. Live Twitter.
Okay, okay. How many such data you have taken?
For the training, sir.
Yeah, training.
We have like among like 50,000 tweets data set it contains. We have trained on that, sir. Like 50,000 tweets.
Take, okay.
Yeah, thank you, sir. Thank you for giving this opportunity.
Thank you, Bhanu, for your presentation. Now we have Abhishek Shrivas presenting their paper titled Patch Attention Efficient Net V0 Framework for Multi-Class Weed Species Identification using Deep Convolutional Neural Networks.
Actually, I don't have a rights to share. Can you please give it to me?
Try sharing now.
Yeah. Okay. I hope now it's visible. So, good afternoon, everyone. I am Abhishek Rajesh Shrivas and I am from VNIT Nagpur. Today, I am going to present our work, which is a patch attention efficient net B0 framework for a multi-class weight identification. The ultimate objective of this research is not only to identify the weed species, but to build the first step toward a AI-based compost recommendation system. Different weeds have a different chemical compost and decompose rate and nutrition value.
Excuse me,
So
Abhishek.
yeah, ma'am.
Please turn on your camera.
Yeah, just a minute, ma'am. Excuse me. Sorry for inconvenience. And let me share again. Is it visible, ma'am? So
Yes, it's visible.
so our problem statement is like agriculture generate a huge amount of plant waste every year. Almost a farmer often cannot determine whether this particular waste is they can reuse it or not, because there are the lots of specific plants which have a good for their field and bad for their field. There are multiple weed species which are having a nutrition for their field and having a toxic content for their field. So are basically this model help them to identify how to identify which particular plant and which particular like toxic plants have helps you to have a is it good or bad for your agriculture field. So basically in my literature survey, I have done almost a lots of literature survey, and each and every paper is to identifying a specific plant category whether it having a disease or not. But what about the plants which are like foreign bodies for that particular field? And the weeds are not only the plant which are harmful for the soil or only for crops. Sometimes the weeds are also good for a field if it is used in a right manner. And after reading each and every paper, they I come to a conclusion that they are only answering which type of the disease and what type of the plant it is. They are not answering the farmers questions, which are the major four questions. Can this weed be composted, and if it is composted, which type of compost it should be, like safe compost, hot compost, or normal compost? Is it toxic? Does it require a like special treatment? Which crop benefit from this compost? So we are going to answer in this paper. We have answered about the first question of the farmers, like can this weed is useful and compostable? So basically the contribution of these papers is like we have created this particular data set from by collecting farm to farm, from forest to forest. And we have also introduced a lightweight CNN, which is capable of like inbid into an Arduino, or you can also use a ESP32 to like hold and to use a model on like specific microcontrollers. Second, we have also third, we also have a particular matrices to validate these things. And fourth, we have also tested this particular thing on a uh, like on a field. So we got a good results. So about my data set, so basically in this data set there are the 13 species, and this 13 species has been collected from the forest with the help of forest bodies, with the help of a Nagpur agriculture department. And this data set has been recognized and built in the coordination with the VNIT EC department and a agriculture department from a uh, forest department. So this is the like my architecture, in which we have like here you can see in the input layer we have a number of images. We have collected a like not a random image, but a random dimension images. Like some images are 224 into 224, some are 251 by 251. And then we have done a pre-processing. In pre-processing we have done resizing, data augmentation, rotation, then normalization and splitting, which are the normal things basically we do in a pre-processing. After that we have the main block. In the main block we have used an efficient net bo. Why efficient net bo? Because it is pre-trained model, and we don't need the things to be re caliber and re have that things. So basically we have used an efficient net. And one more thing which makes this particular model more efficient is like we have three specific things. One is like one is like MD convolutional block, depth-wise sequential convolution, and sequential and uh, executions. So basically, this helps to identify the particular leaves in a proper manner, the age, the textures, and what type of the whenever we use a CNN, the CNN basically let me explain it with an example. For example, we are talking about a neem leaf. So the image is in a 2000 into 2000, and we are reducing it to into a 224 into 224. So we are not like the small vents which that particular leaf have. It might be disappear because we are doing our image downsampling. So for that, what we have come to in a conclusion, we will have a four blocks patch focus. So one is on the right, on one is on the left center, then two are on downs. So specifically this patch will focus on the targeted area, so that we could not just leave the information which are the most important information to give a classification to our model. Then we have preserving our like fine details using a multi-patch abstraction, which I just explained, and a dual attention ahead. And we also have a backbone classification, like which we are using MV convolutional block and depth-wise separation, extracting 1280 vector classification. And we are also using a batch normalization and dropout, because mainly when we are having that whole complex architecture, during that time we discovered that our models are getting overfitted. So for removing that thing, we just use a dropout. Yeah, here is a training protocol, whatever like we have used in standard. So here are the results. The thing which efficient net b0 having accuracy of 90.3, and we are also we are getting a training accuracy 96.1. The difference is much higher, but we are aiming to have we are aiming to reduce the difference between training and validation. And we are recollecting all the collecting more photos, so that the machine can get learn in a detailed manner. Here is a convolutional matrix. Here you can see we are getting a high accuracy for mount seed and neem leaves, because we have a good amount of data. But in little bell we are getting a 87.5 in our test state, because we are getting because we don't have that much of data. As I told, like we have collected minimum 500 photos of each classes. But as compared to the neem leaves, we have a less data of a little bell. Now here is a ROC curve, like per classes wise, and here you can see that it is higher for some seeds like neem leaf and other leaves, but it is much lower side for the some like tobacco leaves, uh, little bell. For this type of the things, we are having a like low accuracy rate, but it is still more than the 85%. And now we have this particular image has been taken from a ground, and we have clicked a photo and given to our application, and it was perfectly predicting that this class is belongs to Amrestons spinus, and with the accuracy of 100%. And here it is like a distinguish about how this particular application serving mainly like how we have got all these things. So we have trained our model onto an Q4000, which is a one of a GPU known for like warehouse and high computational, with the epochs of 20. And we got a 90 the accuracy between 92 to 93. So here is a, a patch to small smartphone scalable precision. We are planning to increase in a future. We are planning to increase this particular data set. Plus, we are also planning to have this model to be fit into an application which will be help farmers to identify which is good and which is bad. And we are also planning to like connect it with a Raspberry Pi and a microcontroller, so that we can deploy it into, like, a farmer can have a small device and he can scan his whole farm. So these are my references, and thank you.
Very nice work. So you're doing the PhD. This is a PhD topic?
No, sir. I have done I'm doing a MTech right now. Like, I'm a final year student, and
So what is your target audience right now? Have you specified the target customers like farmers from the different regions?
basically, my BTech project was also from agriculture only, same. So I'm just extending these things, and the targeted region for my whole thing is for Maharashtra, and all the 13 species are collected from complete Maharashtra.
Yeah, so 13 species. From which region you have collected it?
Sir,
Do that region have the scope to use this application? Do you have
yes.
mentioned that?
Yes, sir. Actually, I have collected it from Nagpur district, Nagpur, Varda, and Savne. These are the three regions from where I have collected these things, and the total yield, like almost this particular region, waste almost in every month they almost like a tons of like huge particular 13 species. They almost burn a huge of tons without knowing that this particular species can help their soil to have a good like nutrition values.
Yeah, but how you are going to help them
Okay.
with the result that you are getting from this?
Okay. So we are VNIT have taken an initiative. We are creating we have one particular project which is like agro waste management. So we are planning to add this model so that it will help a farmer to identify which type of agro waste he can classify.
So better you try to approach the government first, because government, if they
Yeah.
understood, then only they will.
So government is already working with us. Like I already tell in the starting only, like this data set has been collected by VNIT and government bodies.
Mhm. Okay. So are they going to put some funding to deploy it into the different region?
So right now, till now, we didn't have that much like
Because you have to increase the accuracy as well.
Yeah.
Like,
Yes, sir. Yes, sir.
accuracy is 90% only, right?
Yeah.
So that you have to increase. So you have to work more hard and showcase to the government at one point if they show the interest. No.
Yes.
ठीक. Okay.
Okay. Thank you very much, sir.
Thank you, Abhishek, for that presentation.
Madam, how many remaining right now?
Sir, two left.
This is the last one?
No, so this is the second last one.
Okay. ठीक.
Now we have Chandra Kanta Yadav presenting their paper titled Sindhi at the Digital Crossroads, a survey of lexical resources.
Yes. I'm audible, sir?
Yes,
Sir?
Yes, ma'am, you're
yes,
audible.
yes. Yes, you are audible.
Chandra, you may please start your presentation.
Yes, ma'am.
Are you facing any technical difficulties?
This is visible.
Yes,
Yes,
make the
it's
slide
visible.
show.
Okay, sir. Good afternoon to respected session chairs. I am Chandrakanta Yadav from Vanasli Vidyapith. I am going to present our work titled Sindhi at the Digital Crossroads, a survey of lexical resources. In introduction, this work reviews the available lexical resources for the Sindhi language and analyze their role in natural language processing. In introduction, language digitization is essential for preserving low resource languages. Modern NLP applications require digital linguistic resources such as dictionaries, corpora, and lexical database. However, Sindhi still lacks sufficient computational resources, which motivates this study. Importance of lexical resources. Lexical resources form the backbone of NLP systems. They provide linguistic knowledge required for applications such as machine translation, information retrieval, text classification, and word sense disambiguation. Without these resources, NLP system cannot perform effectively. This is the related work in Sindhi language. In related work section, we categorize the existing literature review based on the lexical resources, where we found that very few work in the Sindhi Devanagari compared to Sindhi Perso-Arabic script. Word sense disambiguation. Word sense disambiguation is the task of determining the correct meaning of a word based on its context. For example, the word bank can mean a financial institution or the side of river. Lexical resources help computers identify the intended meaning. Resource poor language. Many regional languages, including Sindhi, are considered resource poor language because they lack annotated datasets, digital dictionaries, and NLP tools. This creates major challenges for developing intelligent language technologies. About Sindhi language, Sindhi is spoken by nearly 75 million peoples across India and Pakistan. It is written in two scripts, Perso-Arabic and Devanagari. Supporting both scripts make NLP development more challenging. Challenges Challenges in Sindhi NLP. The major challenges include multiple writing system, lexical normalization, script conversion, lack of post taggers, limited machine readable dictionaries, and small corpora. In existing resources include dictionaries, corpora, steamers, and lexical databases. However, these resources are generally small, scattered, and lack standardization. In research gap, our review identified several important research gaps. There are no large-scale lexical resources. Standardized semantic lexicons and benchmark datasets are largely unavailable. Machine-readable dictionaries are limited and interoperability between resources is poor. This figure shows the distribution of Sindhi research according to writing script. Most research has been conducted using the Perso-Arabic script. Comparatively, little work has been carried out by the Devanagari script. This imbalance highlights the need for further research in Devanagari Sindhi. This graph shows that evolution of different categories of lexical resources. Perso-Arabic resources dominate foundational, morphological, and advanced resource development. Devanagari still has limited lexical resources availability. In third figure, this graph presents the proportion of different learning approaches. Rule-based methods are the most commonly used. Machine learning approaches have increased in recent years. Deep learning remains limited due to insufficient training data. Impact on NLP. Due to these limitations, Sindhi NLP applications still suffer from low performance. Machine translation, question answering, information retrieval, and word sense disambiguation cannot achieve high accuracy because high quality lexical resources are unavailable. Motivation of this study. The main motivation behind this work is to systematically review available Sindhi lexical resources, identify research gaps, evaluate their usability, and provide directions for future research. Expected contribution. This survey provides a comprehensive overview of Sindhi lexical resources. It can serve as a reference for researchers and encourage the development of standardized and interoperable resources. In conclusion, we reviewed existing Sindhi lexical resources including dictionary corpora, morphological tools, semantic resources, and word embedding. Our study found that Sindhi remains a resource-poor language, especially in Devanagari script. There is an urgent need for standardized lexical resources to support future NLP research. In future work should focus on developing large annotated corpora, creating a comprehensive Sindhi wordnet, digitizing dictionaries, improving cross-script normalization, and adopting deep learning approaches, supported by benchmark datasets. This is the references. And thank you, sir.
Chandra, can you show the slide one more time?
Yes, sir. Yes, sir. Yes, sir. Okay, sir.
Can you share the slide one more time?
I am audible, sir?
Yes, you're audible, but your screen is not shared.
Again share. Can I again share my screen?
Yes.
Madam, what can you show the result analysis? I never find the result analysis there.
Yes, sir.
So what basically, can you highlight this slide? What is your objective here, madam?
This is the survey of lexical resources in case of Sindhi Devanagari, sir. Sindhi Devanagari is resource poor. So we surveyed the lexical resources of Sindhi.
Okay. But which is your target audience, ma'am?
सर टारगेट ऑडियंसेस की सिंधी एक रिसोर्स पोर लैंग्वेज है और मैं इस पे सिंधी पर भी जो इसकी लेक्सिकल रिसोर्सेज अवेलेबल नहीं है उसके लिए मैं इसी पर काम कर रही हूँ मैं इसके लिए जैसे मशीन रीडेबल डिक्शनरी क्रिएट कर रही हूँ, उसके लिए फिर मेरे को जैसे पूरा डिजिटल कॉर्पोरा बनाना है मेरे को, तो इसी पे वर्क बना रही हूँ मैं, बना लिया मैंने जब लगभग, और इसी का मैंने जैसे एग्जिस्टिंग रिसोर्सेज देखा है कि इसमें कुछ भी हिंदी परसो अरेबिक में तो अवेलेबल है, पर सिंधी देवनागरी में अभी कोई भी लेक्सिकल रिसोर्सेज अवेलेबल नहीं है।
तो कितने यूजर रहेंगे इसके अगर ये आप करते हो तो?
सर ये मैं रिसर्च स्कॉलर हूँ, तो ये मैंने जो दो डिक्शनरी को यूज किया है, और उनको डिक्शनरी को मैंने एमआरडी फॉर्म में बनाना है मेरे को। मैंने ऑलरेडी इसमें 70% वर्क हो गया, और इसका आगे वर्क चल रहा है मेरा।
तो ये तो आप वैलिडेट किससे करवा रहे हो? हु इज वैलिडेटिंग योर रिजल्ट?
सर मोंगोडीबी और पाइथन।
नहीं, मैंने वो टेक्नोलॉजी हो गई, मैं आपको बात कर रहा हूँ कि ये इसको अगर एक बार बनने के बाद इसको वैलिडेट कौन करेगा, ऑथेंटिकेट कौन करेगा इसको?
सर बनसली में एमटी सिस्टम वर्क कर रहा है, इसके लिए पहले ऑलरेडी प्रोजेक्ट्स वर्क कर रहे हैं।
So what I'm trying to say, work is okay that you are working, but there should be some authority to validate your foundational lexical resources, your morphological resources, data-driven advanced resources that you are using right now. The study must be validated. All these Devanagari results. So you need to connect to the authenticate person to validate your result, madam. Otherwise, you will publish paper, but it will ends with only in publishing that. That's it.
सर हम जो भी डेटा सेट क्रिएट करते हैं वो लैंग्वेज एक्सपर्ट से चेक करवाते हैं कि जो हिंदी देवनागरी का है, उसी से हम एक्सपर्ट से चेक करवाते हैं कि डेटा की हमारा करेक्ट है, उसी के बाद एमटी सिस्टम से हम उसको चेक करवा रहे हैं कि हमारा
ओके।
और उसके लिए मैंने 25,000 का डेटा टारगेट किया है।
ओके, गॉट इट
ओके, थैंक यू सर।
Thank you for your presentation, Chandrakanta. At last, we have Praveen Pavaskar presenting the paper titled Soil Sense to Crop Care, Unified Deep Learning Architecture Integrating Pedological Analytics and Phytopathological Detection for Autonomous Precision Agriculture.
Is my screen is visible, sir? Hello, am I audible?
No, not yet, sir, not yet. Yes, it's now visible, yes.
Sir, can you hear me?
Yes.
Yes. Good afternoon, sir. My name is Praveen Pavaskar, and my paper ID is 2037. My topic is Soil Sense to Crop Care, a unified deep learning architecture integrating pathological analytics and pathological detection for autonomous precision agriculture. My name is Praveen. I'm based in the Bangalore, belonging to MSRIT, and my co-authors are Yogesh and Deepa. Coming to this particular topic, this work proposes the integrated artificial intelligence framework that combines soil analysis with crop disease detection to support precision agriculture. Throughout this presentation, I will be explaining about the motivation, methodology, experiment results, as well as the advantages of my proposed system. Coming to the motivation, as you know that our country is basically based on the agriculture, and agriculture today faces several major challenges like climate changes affecting the rain patterns and soil quality. All these are contributing a lot to, and at the same time, farmers face crop disease, declining in the soil fertility, shortage of the skilled labor. So there are some challenges are there, and in order to tackle this one, traditional what is happening is in traditional farming practices often respond to the problems only to the when it is severe. So that is the problem with the current scenario, the farmers will take this particular issue only it is severe. Therefore, there is a growing need for intelligent system that can predict the problems early and support better decision making. So, coming to the research problem. So most existing research focuses only on one particular aspect of the agriculture. Some studies predict the crop yield using the soil information, while others detect the diseases. So these are the two different aspects are there. So what is my main intention is they do we should not treat these two approaches independently, even though as they are very much dependent on each other. We need to combine these two things. So my main goal is to develop an one unified AI framework which can handle both of these things together. So coming to research objectives, the proposed work aims to predict the crop yield from the soil properties, detect the crop diseases from the images, integrate the both the models, that is the soil properties and the disease information, and support the precision agriculture and enable the edge development. So this is how the we can have the pictorial representation of the entire flow can be taken. So our main intention here is to have a better management of the climate thing, soil information to be taken, and ultimate goal is to have the better yield. So proposed framework has two integrated modules, one by name Soil Intelligence Module, shortly we can call it as a SIM, and another one is a Visual Pathology Module, which is VPM. So one is based on the detecting the soil values, and the second one is taking the information of the leaf diseases. So what is the output? We are going to have this crop prediction, disease diagnosis, and decision support. So data set is I am taking from the Kaggle, and again it is a combination of the real data set also taken from the um, a digital phone and digital cameras. So altogether, these data sets provides me the information of nearly 15,000 soil information related to different climatic regions about three crops, that is cotton, tomato, and wheat, and soil features. And for disease detection, I have the data set with 25,000 images of cotton, tomato, and wheat. So coming to the soil pre-processing, there are some missing value will be there, and these things can be compensated with the process called as imputation, score normalization, and one hot ending. And image pre-processing can be done for the with the various techniques like cropping the image, enhancing the image quality, data augmenting, and image normalization. So this is the complete way in which we can take the different layers. So we can make use of the feed forward deep neural network, and these information are given to these things, and input is taken to the dense layers, which again then taken to the batch normalization. Then we are going to have the dropout, residual connections, and finally the yield production will be taken. So coming to the main thing, why I'm dealing with the residual connection. The advantage is being it prevents the vanishing gradients, better convergence will be there, improved accuracy will be there, and stable training can be done for these information. So I have a model, and that is efficient net B0, which will be used basically for attaining the high accuracy, low parameters, and fast inference, and suitable for edge devices. So this is the complete flow how the information can be taken for the entire efficient net B0 network. and finally we can have the proper information. So coming to the modified classifier, we can have some information which can be taken into consideration for dropout and given to the dense layer and batch normalization, finally given to the softmax. So training procedure followed. So we will be transferring the training Bayesian optimization is being followed. Uh, s- Stratified cross validation, focal loss, and Adam optimizers are being used. So this is the complete experimental setup I have related to the um, experiment setup. I will be using the TensorFlow along with the Python, and my main aim is to attain the proper accuracy using RMSC, MAE, and R square and FN square. So this is the result which I have got with respect to the performance. It is R square value for cotton is 0.912. For wheat it is R square value is 0.896. For tomato it is R square value is 0.883. So if you see the entire result, what we can obtain is the Oscar square is near almost nearing to the one, and it gives a better result. So there is a comparison between the different values obtained here. That is the MAE value, RMSE value, and R square values. So coming to yield classification, the yield classification gives this particular um, accuracy value of 94.7 for um, task description with very we have different classes here, very low, low, medium, high, and very high, as well as for the other one we have 95.7. So coming to the disease detection, we have accuracy for three different crops we have identified, that is cotton, tomato, and wheat, and these are the different values. So with our experiment, what overall accuracy obtained is 96.8 for the cotton, and for tomato it is 96.3, and for wheat it is 95.7. So this is the benchmark comparison. So I have been compared with the different models available, that is VGG16, RS50, MobileNet, and DenseNet, proposed VPN. So coming to application and limitation, nowadays farming is taking having so many different changes because of the technology available, because of the data available. So we can go ahead with the smart farming, in which the farmers can make use of these values much in better way. Precision agriculture definitely helps them to get the exact value of the different conditions and the quality, and they can do the exact they can plan, in fact they can plan how exactly they can go for the cultivation. Then uh, there are different IoT based forms we can also do. We can have some IoT based devices which can help the farming. And limitations being I have been focused on the very three crops only. We can extend it for the other crops also. We can take many more soil parameters. What I have used is the only 6 parameters, and we can extend the information to the different data sets, and even the seasons variation can also be included. So overall, what I can say is my efficient net B0 has the accuracy of a yield classification as 95.7, and disease detection is 96.3. So this gives the better make use for the better agriculture. And this is my future enhancement. We can go for the more and more crops. We can integrate with the different weather conditions which we have not considered. and satellite imagery also can be taken into consideration so that we can have a better farming. Even nowadays, drone monitoring is catching up, so we can take the information from the drone information, and explainable AI and LLM based farm assistant can also be used. And these are my few references. Yes, sir. Hello?
Yes, sir. Yes. Very nice work, sir. So, sir, government of Karnataka is already deploying some drones technologies to detect the disease, soil health monitoring,
Yes, sir.
and now you are going with the traditional methodology.
Yes.
How people are now uh, matching the speed of the recent trends in technology and your work?
Because there are so many different farmers are there, sir, for whom the technology is still not reachable. We can reach out to those kind of farmers, and we can assist them, and we can also take them to the modern techniques by proper assistance, proper guidance. We can do that one, but to start all those things, this we have to start from one particular point, and we can make use of this information to them.
So, have you tested in a real-time soil?
Yes, sir. Yes, sir.
So, what is the difference between the Kaggle dataset that you use and the model train on that and the real-time testing?
So result is almost the result what I'm going getting for the real data as well as for the Kaggle data. There is slight differences there, but my real I'm trying to minimize this particular gap so that the actual value can be taken.
Okay, good work.
Okay, sir. Thank you. Saraswati madam, can I leave?
Now we're done. Let's just do the closing remarks and we'll end the session.
This is the last one, Saraswati, right?
Yes, no, we're done. We are done with the presentations. We'll just do
We are
the
done.
closing. Yeah, all the presentations are
Okay.
over. With this, we've come to the end of this session. I sincerely thank all our authors for the excellent presentations and valuable research contributions. I'd also like to thank all the participants for being a part of this session of the 11th International Conference on Information and Communication Technology for Sustainable Development, that is ICT4SD 2026. I hope you found today's session informative and interesting. On behalf of the entire organizing committee, we extend our heartfelt gratitude for your continued support, not only for the 11th edition of ICT4SD, but also for all the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All the presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I would also like to extend our sincere gratitude to our session chair for effectively chairing the session, and as a token of our appreciation, we present this to you, sir.
Yes, thanks,
So,
Sanskruti. Thanks, all. We'll connect. Anna.
yes, sir.
Yes, thank you.
Would you please like to share any closing remarks before we end the session?
Pardon, Sanskruti?
Would you like to share a few words before we end the session?
No, it's
Closing
good that you evaluated my own way. I've not gone to the much depth of the technology that these scholars or the students, UG students, PG students have presented during this conference. But what I want to say is that unless and until these results is not going to use in a real-time environment, I think we should not say that the research is completed. So my sincere request to all these participants to have at least a patent to of the copyright and to check the commercialization aspect of it, real-time testing use cases, and actual field work where this research can be deployed and tested successfully, so that many of them can use it effectively. So that is what is my suggestion to all. Thank you.
Thank you for your feedback, sir. We truly appreciate you taking out your time and being here today. Now,
Yes, thank
before
you
we
very
end
much.
before we end this session, can I please request everyone to please turn on their camera so that we can have a quick snapshot of this session. Okay. Thank you everyone for joining us today. Have a great day.